our isosceles triangle. This picture is going through just the different like parts of it, which you need to know because we'll have word problems where it's just saying like, oh, the base angle is this, the base is this, or the vertex angle, whatever. So a vertex angle. All right, let's start with the legs. The two legs are the two congruent parts of your triangle. The base is the non-congruent one. And then the vertex angle is the angle made from the congruent, there you go, legs. And it's the one angle that doesn't match the other two. And then your base angles down here are the ones that are congruent. They are opposite of the legs themselves. So what that means is like you go across, it's the opposite of the leg. That's what it means by opposite. So like if you just draw an arrow just straight out of the, if you draw an arrow straight out of the angle, it points at the opposite leg. That's what it means because it'll say it in like some word problems every once in a while. Like the base angle is 45 degree or 50 degrees, and its opposite leg is however long. So if it's referring to the opposite leg, it just means cross. Okay, that's all your basics. From an isosceles triangle, we're going to look at some theorems. So we have the base angle theorem and then the converse of it. The base angle theorem is saying if you have two sides that are congruent, the opposite angles, so the angles opposite of them, so referring to these two angles, base angles, are also congruent. That's your base angle theorem. So you start with the leg, and then you get to say the angles are congruent. The converse goes the other way. So the converse starts with the angles themselves, and then you get to state that the legs are congruent. So just knowing that the regular one starts with the legs, goes to the angles, converse goes from the angles to the legs. Then our corollaries that go off of that, because remember, a corollary is something that's like directly attached to the theorem. So the corollary of that base angle theorem is talking about our equilateral triangles. So if it's equilateral, then it has to be equiangular. That's the corollary to the base angle. And the corollary to the converse is saying if you have it as equiangular, then that triangle has to be equilateral.
What's that?
It's an attachment, or it's a direct statement you can say from a theorem. Okay. So then for our examples down below, if this is our statement that HG is congruent to HK, what can you then say after that? Yeah, angle G, so this angle is congruent to this one. Yes, that's going to be your statement. Now, how to write it? We could describe angle G with one letter, like G is the only angle that is there. But K, that's not, the one that I have marked isn't the only angle. So we would have to use 3 letters to describe it. And just like proper ways to write stuff, if you have to use 3 letters to describe this K angle, then you need to use 3 letters to describe K. So writing it as angle HGK is congruent to angle HKG. Since one of them is 3, you want to use the other 3. Okay, and so we were starting with the segment, then got to the angle. So what theorem is that, Grace? Just the base angle theorem. Okay, same picture. New start. If we have angle KHJ, so this angle, and KJH, so this angle. So we have 2 angles that are congruent. What's the statement we can then say?
Segment
Correct. HK is congruent to JK. JK? So that one we started with the angles. We were able to say a segment, which means what is our theorem of that? Converse, correct, of our base angle theorem. Done with theorems until we get to the one proof we'll do at the very end of the class. So for these, it's just going through and finding the different measures, or the, actually this one. Wrong thing. Say again? Okay, so since this is 50, then these would have to add up to 130.
And they should, and since the segments are the same, the angle should be the same.
So what should the measure of each angle be?
65.
65. So the measure of angle x equals 65, measure of angle z equals 65. What about the second one?
X is 8.
Yep, x is 8 because it has the markings on the other side. But y?
62.
62, correct. Because 56 would have been our vertex angle. That's something to just keep in mind, like the vertex angle isn't always the top when you have a triangle. So your marking.
Wait, how do you know that that was vertex?
Because the two sides that are congruent form the vertex angle. Okay. What about these ones?
Ours is covered up.
Yeah, ours is covered. We don't have the numbers.
On the
I was
top one.
confused. Instead of Y35 and X, we just have 3 gray spots.
Yeah.
Oh, that's weird. Okay. Well, then let's do this one together.
X is 35.
Okay. X is 35. Good.
And Y.
What's true about that 35 and 35?
Oh, you can
They add up to 70, right?
So that's 110. So that means the other side would be 70. And if that's
You could have just got, remember that exterior angle? That exterior angle theorem? That this angle adds up to those two, right?
That's
So yeah, we still get 70 regardless.
110.
Yeah, so these two angles would add up to 110. So what's half of 110?
Wait, but how do you know they're, how do you know those two angles are equal?
Because of this marking right here.
Oh.
So we know that triangle was an isosceles triangle. Okay. I want y'all to try to do the next one. At least try and get an idea before you get together. So the system way to solve this is the hard way. There's a non-system way to solve it. The reason we have an isosceles triangle here, right? Which means this and this angle are the same. So instead of using this 8y, if I double this and say 48 plus 4x plus the 7x adds up to 180.
Ah.
Because since 8y and the 24 plus 2x are the same angle, instead of creating an equation with x and y, using that angle sum having them all up 180, so 48 plus 11x equals 180.
12.
X equals.
Correct. X.
Okay, stupid question. If you're doing this system, what is the equation between 24 plus 2x equals 8y? But what was the other equation?
8x or 8y plus 24 plus 2x plus 7x equals 180. So what we had up here.
No, I mean, like, if you're solving for a system, would you
Yeah, that would be your second system to solve.
Oh, right, okay, okay.
Okay, so knowing that x is 12, that makes this 48.
And then 48.
So 8y equals 48, so y is 6. Most times with an isosceles triangle or an equilateral triangle, there's generally a way to do it without a system. Not every time, of course there are some times where you have to solve a system, but look for the ways that like maybe you don't have to sometimes, because you do have that repeated angle. Okay. I want y'all to try both of these ones before we go over it.
Not x equals 90.
X is 90, good. Okay, how would you get to that?
Because all three equals 60.
Okay, so all of these are 60.
Oh, I'm confused with this.
And then, the other one is 30. Like the one on the bottom.
Okay, this one has to be 30.
So 60 plus 30 is 90.
Correct.
And I don't know how to do big Y.
Okay, so we got that X is 90 for the Y value. This is a 90-degree angle, right?
Oh.
But I thought it was
But you.
But we just solved it,
Oh.
right?
So it's not.
So now we have a right triangle.
Which means
So this full side is 80. This one, since it's an equilateral triangle, that is 40. So 40 squared plus 8y squared equals 80 squared. Right? Put that in here. 1600. Be really careful with this part when you're squaring. So you have to square both parts. So 64y squared. And then 6400.
minus 1600.
Correct. Which is 4800.
And
75. So since y squared is 75, the square root of 75, simplify that radical. 75 is what? 3 times 25? 7 by 3.
Oh.
Right?
Mm-hmm.
Yeah.
So Y equals 7.
Keep in mind, we are taking the square root. In this one, y was only in this spot. And if it was, so when you take the square root, you need the positive and negative of it. But since the negative of this would make a length negative, so that one wouldn't work. But keep that in mind, we are going to have another, like, squared problem. So just be careful. Anytime there's something squared, don't forget about the negative option. If you plug it back in and it makes things positive and like valid and all that good stuff, then both answers are correct. Okay. Next set of problems, which I want y'all to start first without me, and then we'll go through it.
Wait, all three sides of a triangle, what do they add up to?
The sides? No, there's no rule for it's the angles. So this was equilateral, right? And then since there's markings for the other triangle, that means the second one's isosceles. So did y'all get to this part where you can set up
5 minus 3 equals 1.
that?
And then y is.
So y is 4.
Wait, how did you?
Because.
Because if this triangle over here, all the angles are marked as congruent, so that has to be equilateral. And then on this other triangle, it has 2 angles marked as congruent, so that one has to be isosceles. And since this angle is the same as this one, it makes these two your base legs. No, not base legs. Your legs, which means they also have to be converted.
Okay.
So since y is 4, that makes this 16.
3x squared minus 32 equals 6.
Correct. So 3x squared minus 32 equals 16.
And then I have 3x squared equals 4.
Wonderful.
We divide that by 4, so minus
16.
16.
And then, so, okay, now when you take the square root,
Or negative.
positive plus or minus 4, would both numbers, the positive and the negative value of 4, plugging back in, be okay? Look where x was. X is being squared here.
Yes, because no matter what you square with, it's gonna turn out positive.
Right. So you would write plus or minus 4. So both answers. Make sure you include both always.
For x or for anything.
Whenever it's possible. So just make sure you're always checking back with your problem. Like, oh, does that number make sense for it? Like, can it still be a valid answer with the positive version and the negative? Sometimes it's yes. Sometimes it's no. So you only have one of the answers.
Do you ever end up with a negative side or
No. That's when you wouldn't count it.
as long as it goes in positive?
Correct. As long as it will turn the side length positive, you're fine. It's a good answer. Okay. What about that next one?
X equals 60, y
Okay.
equals 20.
X equals 60. It has all the markings of an equilateral triangle, which means this is 30 and this is 30. Correct. All right. Last part of our notes. Go ahead and do both of them. On the second one, if you struggle, at least draw the picture and like get it set up, and then we can solve it together. Like the paragraph one,
Oh,
because that paragraph is a separate problem.
oh.
So do the problem on the top, and then if you're struggling with the paragraph of setting it up, try to at least get the picture drawn.
4y plus 1 equals 50 equals 1.
Huh?
That's what I.
First, I figured out the two angles on the bottom, which is 180 minus 50 divided by 2,
Right.
and that's 65.
Okay.
And then I 65 equals 2y equals 64, which is 1/2.
Wonderful.
Okay, is that 50? Wait. And then I know how to solve it because 65 plus blank equals 180,
Okay.
or 60.
What's the blank?
115, and then 115 divided by 2 equals something, and then I didn't solve it after that, I was too lazy.
What's half of 115?
Yes.
Correct.
Wait, wouldn't?
Wait, not half of 115. It's half of 65, right? Because these two angles would add up to equal 65.
Because.
Oh, because the outside angle.
Well, just because if this one's 115, then the other two have to add up to 180,
Oh.
right? So half of 65 is what that x equation should equal. So,
Oh, I could have just multiplied by 2.
or that, yeah.
Because that'd be easier if you don't have to do that. I did that, but I got 50. It's
50's right.
It is 32.3.
Wait,
but because 50 is x.
50's x, not the angle, right?
And then 45 minus x minus over 4 is equal to 32 point whatever.
And then we multiply by -4 on each side. Yep.
See, that's what I probably could have used the calculator.
Yeah.
Okay.
Did y'all get to the second one yet?
No.
Okay, I want you to read it and draw the picture, and then we'll go through it.
Okay.
Did you say, okay, I think you maybe, did you get to this?
Yes.
Yeah.
Okay, so then make one side 0, so 4x minus, or x squared minus 4x plus 3 equals 0.
Yeah, that's right. That's right. I remember.
X squared doesn't have a coefficient, or a coefficient of 1, which is the easy one. The numbers that multiply to give you -3, but add, or multiply to give you 3, but add up to -4. So your two x values would be 1 and 3. plugging those numbers back into the equator, into those side lengths, would both of them be okay?
I don't know.
Well, let's test it. Let's take the 1. So we put a 1 into this, or for DO, that's 1 squared plus 1, so 2. Okay, that's a big deal. And then we would have 2 on this side as well. And we put a 1 in down at the bottom for the base, that'd be 2 times 1 minus 3, which is a negative.
So that can't work.
So this one is not valid. So when it's asking for all the different lengths, we have DO, OG, and then DG.
DO is 10. And
D
OG.
is 10, OG has to be 10, and then
And another way is that like 10 plus 10 is 20, 20 is greater than 3, 3 plus 10 is 13, 13 is greater than 2. You know that way that people like, that like you can check if like, what's it called, like 2 angles have to add up and they have to be greater than it's 5.
we'll do that this year. That'll be on. Huh. I can't remember if they're doing it before or after Christmas, but we're gonna see. Okay, that was the end of our like practice work through things. We're gonna do one proof together. So on your other paper, go to the back, take number 9. This is the complicated proof. So we are doing the complicated proof together, and I'm leaving the easier ones for you to do without me. The reason this is complicated, it's got a few things. First thing, if you look at that, we are proving 2 different things. We are proving 2 different sets of triangles are congruent. One of them, this first one, is,
Wait, is it not by power for 7?
it's already written in there for you. You see that C-chart?
Oh.
It's already written in. So the first one that we're proving are these triangles. The second set of triangles that we're going to be proving, so this set is going to be these triangles. So how to know what to prove first? Well, it gives it to you in order, but the second way to know, the first thing that we have to prove is the larger set of triangles. The first thing we are proving is with these larger triangles.
Can you prove them on side?
It's
Okay.
isosceles.
So we know it's isosceles. So since it's isosceles, we can say, and it says that P is our vertex angle. That is very important to mention in a proof when we have an isosceles triangle. That way, since we know that P is the vertex angle, that means PQ and PR are the legs. So we can say that PQ is congruent to PR, and that's just your definition of isosceles. And now let's think back to what we were doing before.
Because the lines is in
PT is congruent to PT. That's perfect.
Okay. How is that going to now be helpful?
Because then P, T, and Q are, but I mean,
Because are we going to be able to say, if you want to use side, is there something we are given where we will be able to say QT and RT are congruent?
yes.
Does it say T the midpoint?
wait.
It's bias.
Oh.
It says we have something about perpendicular, but we don't have anything about.
Well, isn't that QT said it there? Oh no, that was right because
Okay.
the angle side done. Oh no, wait.
Right. So let's go. So what's one of our new theorems that we just did today?
Angle theorem.
Okay, so we have 2 options. One, exactly what you're saying. We know that perpendicular lines form right angles, so we could use reflexive with that PT, and then use hypotenuse leg. 100% we could do that. I'm going to go the route of using our base angle theorem, just so we have a little bit of practice with using that new theorem and like things to do from there. I'm also gonna show y'all the reason I also want to do it that way. There is an unnamed theorem, like it's just like a statement that's in our book that we're allowed to use in proofs that we haven't talked about yet. I just want y'all to be able to see it. That way you can use it in the future if you want to. It shortens up a proof quite a bit, so we'll go through it. So I'm going to use that base angle theorem. So saying that angle PQT is congruent to angle PRT by the base angle theorem. So we just got this part. And now the other part that is the unnamed theorem is just something that we get to use. Since we have things that are perpendicular, our unnamed theorem is that perpendicular lines form congruent right angles. I can't remember what page it's on. It's somewhere within our book. I'll find the page and tell you on Monday, but it's just something that we get to write. And why or how this reason is now helpful, instead of having to go through the process of saying the perpendicular lines form right angles, the right angles equal 90 degrees, which means they're equal, which means they're congruent, we just get to say this. And we just get to say right away that angle PTQ is congruent to angle PTR. And now look at my markings. Angle, angle, side. Or triangle PQT is congruent to triangle PRT. Which was the first thing we had proved. That's why we're doing it together. It's like two proofs in one. But the good news, things we figured out in this proof can now help us to figure out the other triangle. So I'm going to go back, I'm going to change my colors out. Well, this is congruent to this is congruent to that. We have this marking, and now we're trying to prove that these two triangles are congruent. So on those two triangles I just highlighted, there's only one set of congruency that we have so far that is useful. What part? Right, PQ is congruent to QR, or PR.
Can you not say that like Q is still congruent to this, like the smaller?
Well, so here's the issue with these base angles. Q is congruent to R, though, like the full angle, but we would need a comment about the tiny angle within it.
So Q, we would have to say S.
We can use CPPTP,
How do you remember that?
but it's not for this part. What it's for, our original triangle, that big triangle, was this one.
Yeah.
You see how we have an overlap right there? So we could say that angle QPS is congruent to angle RPS.
Here's homework.
Yes. The last step for this would be reflexive, that PS is congruent with PS. And then it would be side angle side to be done with the proof. So it has two steps left. But yes, the rest of these are homework.